Hey guys, it's Mr. Walker here, and welcome to another math lesson. Thank you guys very much for joining me today. Today we're going to be kind of combining a couple lessons, a couple concepts into one lesson because I think you guys are super smart, you're super with it, you've been doing a great job. I think it's going to be feasible for us to do this. Basically what we're going to be looking at today is how we can add and subtract numbers that are over one whole. Okay, so these are like your mixed numbers and things like that. So we're adding these fractions that are going to have either sums that are greater than 2, or we're going to be subtracting fractions in mixed numbers that are going to end up being less than 1. So we're going to go through a couple examples together, and we're going to be using a lot of the same strategies that we've already been using. We're going to be, if you feel comfortable using like the number line strategy, if you feel comfortable using the boxes and drawing and dividing into different boxes, or if you feel comfortable just finding those common denominators using the multiples, any of those strategies will work. I'm probably going to stick to the multiples and a little bit of the number line just to kind of illustrate some things, but again, whatever strategy feels most comfortable for you guys, you can go ahead and use that. So let's jump right in with an example. Just make sure you have something to write on, something to write with, and then we'll get going. Alright guys, so I'm starting here. We're doing some addition first, and we're adding two fractions that are more than a whole. So I have here 2 and 2/3 and 5 and 2/5. And you can see right off the bat that our fraction units are different, right? We have thirds over here, we have fifths over here. So I can't add these super easy right off the bat. But what we can do is we can add those whole numbers. So I'm going to illustrate with a number line real quick, right? Just to kind of show what's going on here. So if we think like, let's say 0 and then 1, 2. Okay, so I have up to 10. I'm not going to need to go that far, but just to kind of give a better idea of what we're looking at here. So I could start at the very front of this number, and I know I'm going to be having 2, right? 2 whole. So that would be, let's see, if I'm starting at 0, that'd be 1, 2. So I'd be right here to start, okay? And then I could add that 2/3 first, but actually I'm going to add that 5. So do 1, 2, 3, 4, 5. So that would bring me all the way up to 7 here. So I did plus 2 plus 7, so now I'm at 7. So I took care of this whole number and this whole number. And when we're adding these mixed numbers like this, that's going to be the best way to think about this, right? Get those whole numbers out of the way first, and then we'll come back and take a look at our fractions. So just to kind of illustrate what's going to happen, I'm going to have to add 2/3 and then 2/5, right? So plus 2/3 and plus 2/5. And again, I can't add up these fractions yet because I don't know what I got to find that matching unit. But I know it's going to be above 7, right? Because I did my whole numbers first. So plus 2 and plus, I'm sorry, this should be plus 5, which got me to 7, right? All right, so let's find some common units. So far, like if I wanted to rethink this a little bit, I have 7 plus 2/3 plus 2/5. All right? So I really have to add up these two fractions here and then add them to my 7, and I should be good to go. So let's think of some common multiples of 3 and 5. If I count by 3s, I have 3, 6, 9, 12, 15. Oh, and I know if I count by 5s, I'll get 5, 10, 15, right? So I think my common multiple here, my common denominator, is going to be 15. Again, another way I could think of it is 3 times 5 is 15, 5 times 3 is 15, right? So I know to get 3 to 15, I'm going to have to multiply by 5. I'm going to have to do the same thing to my numerator. 2 times 5, that's going to give me 10. I know down here, 5 times 3 will give me 15. 2 times 3 will give me 6. So now I'm just adding 10 fifteenths and 6 fifteenths together. And if I add those together, and I still got my 7 over here, right? If I add those together, I'm going to end up with 10 plus 6 is 16 fifteenths, right? So now I have 7 and 16 fifteenths. But wait a second, now this 16 fifteenths, that's more than one whole, right? 15 fifteenths is one whole. So let's think of it even further as this. 7 plus 15 fifteenths. Then I'd have that one more 15th left over, right? Because 15 fifteenths plus 1 15th is 16 fifteenths. So I kind of just split it up to illustrate it there. This is one whole. So really I have 7 plus 1 whole, which would be 8, plus 1 15th, which after all that would mean that I would have 8 and 1/15 as an answer. Okay, so really not much is changing in the strategies that I use. What's really changing is that I kind of got to pay attention to my whole numbers first, especially with addition. I could add them first, and then I could add my fractions, find the common units, and add my fractions together at the end. Not too terrible as far as adding mixed numbers. All right, so let's move on to subtraction for a second now. And subtraction is going to be a little bit different, but we're going to be using the same strategies that we've seen all along. There's just kind of like two different ways to attack it and to get to the solution, right? Two different paths we can take to get there. So the problem we're going to look at first is 1 3/4 minus 6/7. Okay, I have it on both sides here. I'm going to do it two different ways so we can kind of see what's going on. And again, I'm going to start with a number line just to kind of illustrate this. Okay, I don't know why my number lines keep going up in the middle, but that's all right. So with this number line, I'm just going to draw a couple in here. So 0, we'll do 0, 1, and 2, because I know it's not going to go any bigger than 1, because we're starting with 1 3/4, or 1 3/4, and we're subtracting 6/7 from it. So we know it's going to be smaller than what we start with. So if I have 1 3/4, that's going to be probably right around in here somewhere. And I'm going to be subtracting 6/7 from it, which is more than half. So it's probably going to put me right around here somewhere, because 6/7 is almost a whole, right? So it's going to land me in here. It's going to probably be less than 1. I'm just not really sure exactly where yet. So let's take a look at this method first and see what we're going to do. We're basically just subtracting 6/7 from 1 3/4. So what I'm going to do is that 1 3/4, again we're subtracting that 6/7 from it. I'm going to think of that 1 3/4 as that improper fraction, as that number with a bigger numerator than denominator. So I know this 1 whole is the same as 4/4, right? And then I have 3 additional fourths. So 4/4 plus 3 more fourths. So let's just write that out so we can see what we're doing. 4/4 plus 3/4 minus 6/7. 4/4 plus 3/4 is going to give me 7/4, right? 7/4 minus 6/7. So we're in a good spot now. I basically just rewrote my 1 3/4 as 7/4. Same amount, same fraction, just a different way of representing it. So now, since my units aren't alike, I need to find a common denominator, a common multiple that they both have, so I can change my denominators to look the same. What I'm going to do is I'm going to multiply these two together to get a common multiple, because I can't think of one that they have in common that's any less than that. So let's see, if I did 4 times 7, that's going to give me 28. And if I did 7 times 4, that's going to give me 28. So my new unit is going to be 28. I just got to figure out how to get there. So 4 times 7 gives me 28. If I do 7 times 7, that's going to give me 49. Okay, and then here I did 7 times 4 to give me 28. I'm going to do 6 times 4, which would give me 24. So now I could subtract. Now my units are the same and I could subtract. So 49 minus 24 is going to give me 25. 25 28ths. There we go. I can't reduce that. There's not a number that I can divide by both of these numbers by. I can't make it any smaller, so there we go. That's my answer. So 1 3/4 minus 6/7 is going to be 25 28ths. There's a second method I could use that's going to get me the same way, but here's how I'm going to think about this. If I have my number line again here of 0 and 1 and 2, right? What I'm going to think about is I'm going to start, instead of at 1 3/4, I'm going to start at just the 1. And I'm going to subtract the 6/7 from it. And that's going to put me probably pretty close to 0, because as we know, 6/7 is close to 1, right? So I'm almost subtracting a whole from a whole. So it's going to put me back this way. But then I can't forget about this 3/4. I'm still going to have this 3/4 left. I subtracted my 6/7 already, but I'm going to have that 3/4 left. So I'm actually going to have to add that 3/4 back on, right? And it's going to put me somewhere in there, somewhere. Don't know where it's going to be, but it's going to be bigger after, even though I'm going to subtract the 6/7, I'm going to end up adding more on and making that fraction a little bit bigger. But I should still get the same answer as I got over here. So let's see what happens. So what I mean when I say I'm going to subtract the 6/7 from the 1 is this. I have my 1 and 3/4 minus 6/7, okay? I'm going to actually kind of separate this out here into, think of my 1 whole as 4/4 and my 3/4. 4/4, 3/4 minus 6/7. But this 4/4, it's just representing that 1 whole, right? Instead of representing that 1 whole as fourths, I'm going to represent it as sevenths. So I'm actually going to get rid of this, and I'm going to rewrite it as 7/7. So now, from that 7/7, that 1 whole, I could subtract 6/7 pretty easily. 7 minus 6 is going to give me 1/7, right? But I got to add back in this 3/4 because that's what my number was, 1 and 3/4, but I've subtracted 7/7 from that 1, left me with 1/7, but I still have that 3/4. So now I got to add these two guys together. I got to find that common multiple, that common unit in order to do that, right? So again, I'm going to do that 28. We know that's a common unit, especially because I just did it over here in method 1. So 7 times 4 will give me 28. 1 times 4 will give me 4. 4 times 7 will give me 28. 3 times 7 will give me 21. 4 plus 21 will give me 25. 28ths, 25, 28ths. We're good to go. Everything is the same. Perfect. So hopefully that's making some sense. You have the two different methods. Either you can change to a mixed number, like I did here, where my numerator was bigger than my denominator, and then change my units that way. Or I could think about my 1 whole and subtract from the 1 whole, and then add back in whatever my original fraction had attached to it. So let's take a look at one more example just to kind of make sure we're kind of understanding what's going on. All right, so for this one I have 4 1/2 minus 3 2/3, right? I'm going to use my two different methods again. So let me just start out here again with a number line. And for this one, let's see, let's go 0 through 5. 0, 1, 2, 3, 4, 5. Okay, cool. So I have 4 1/2 minus 3 2/3. So I'm actually going to represent 4 1/2 right here. Well, let me grab a different color. 4 1/2. It's going to be right here, right about halfway in between. And from that 4 1/2, I'm actually going to start by subtracting the whole number first. So I'm going to subtract 3. So this would be 1, 2, 3. So it would put me right here at 1 1/2. From that 1 1/2, I still have to subtract 2/3 because I subtracted 3 from 4. So I basically got rid of these two guys, but I still have that 2/3 that I have to subtract from the 1 1/2. So I know that 2/3 is a little more than half. So we're probably going to end up like in here somewhere, okay? So I can visually see what's going to go on, what's going to happen here. So let's just walk through these steps now. Okay, so I'll start with 4 1/2 minus 3 2/3. So I'm going to subtract my whole numbers first. So 4 minus 3, it's going to leave me with 1 1/2 minus 2/3, because I already subtracted the 3, so we're good there. So now I got to find the common multiple between these two guys. So let's say 2, 4, 6, 3, 6. Well, it's going to be 6, right? So it's going to be 1 and some sixths minus sixths. So how do you get 2 to 6? 2 times 3 will give me 6. And 1 times 3 will give me 3. Let's see, do this here. 3 times 2 will give me 6. 3 times 2 will give me 6. 2 times 2 will give me 4. 4 6. So I have 1 3/6 minus 4/6. But what I really want to do is this 1 3/6. I want to change it to an improper fraction. I want to change it to where my numerator is bigger on the top, just to make it a little bit easier. So if we thought of this 1/6 as 6/6 plus my 3/6 minus 4/6. So 6/6 plus 3/6 is going to give me 9/6 minus 4/6. and that is going to equal 5/6. Perfect. I could have also done that up here. I'm sorry, I could have actually done it up here too, 1.5. I could have said that that was, let's see, 1 whole would be 2/2 plus 1/2, which would have been 3/2, and then I could have multiplied it and done it that way. You could do it at either spot. I just chose to do it afterwards, so either way is good. You're still going to get to the same answer. That's method 1, okay? Method 2, we had another number line over here with my 0, 1, 2, 3. Oh man, I need another number. 4, that's a little bit better there. All right, so what I could do is I could start at 4, right? And I could subtract 3 2/3. So I would subtract 1, 2, 3, and 2/3. And that would end me up probably right in here somewhere. And then I'm going to have to add back in that 1/2. So I'm kind of ignoring this 1/2 to start. I'm taking that 4, I'm subtracting 3 2/3 from it, and then I'm going to add back in that 1/2, okay? So 4 minus 3 2/3 plus 1/2 is basically how this one's going to work out. So let's take a look at that numerically, see how that shapes out. 4 1/2 minus 3 2/3. So again, I can kind of split this up. I'll keep my half over here, and I can think of my 4. I could think of it as, I'm going to think of this as 4. So 4 minus 3 would leave me 1, but I also have to subtract this 2/3. So 1, which is equal to, if we're thinking in terms of thirds, it's equal to 3/3. I'm subtracting the 2/3 from it, so that's going to be 1/3 left over. So now I could say this 4, basically all that's left out of that 4 is going to be 1/3. When I take 4 and I subtract 3 2/3 from it, I'm going to have 1/3 left. Okay, so now I'm going to have to add my 1/3 and my 1/2 together. Common denominator here would be 6. 3 times 2 gives me 6. 1 times 2 is 2. 2 times 3 gives me 6. 1 times 3 is 3. And 2 plus 3 is 5/6. 5/6. Same thing here. Same thing here. We are golden. So I know it seems like a lot of steps. It definitely seems like a lot of steps because I used 2 different methods to solve this problem. I basically solved this problem twice. You can see whichever one you're comfortable with, whichever one you feel more confident with, that's the one that you can use. I'm totally cool with it. This is you guys figuring out what works best for you. So hopefully this all makes sense. We went over a lot of different examples, not only with adding mixed numbers, adding fractions that are greater than whole, but also subtracting them. So you guys are going to do some more practice with this. Again, it's a combination of 2 lessons, so we're going to be practicing a lot. If you have any questions, comments, or concerns as you go through, please reach out and let me know. Reach out to a learning guide, reach out to a teacher, get the help that you need. But I thank you guys very much for watching. I appreciate all the hard work you're doing, and we'll talk to you soon.